Okay, so let's proceed forward. And you are watching a Foru 5 series that is related to selection gate module, which we have launched. And let me tell you what we have done so far. I think we have, I started with this, XE में fluid mechanics. XE gate paper with XE is something which is very, very important. And I told you that XE में कम effort में ज़्यादा result हमें मिलेगा. But you know, the kind of questions which are asked in XE are different from the kind of questions which are asked in mechanical engineering. There is a small difference in level of question which is asked in XE, because you have to do only 2-3 subjects, fluid mechanics, strength of material, thermodynamics. So the only 2-3 subjects. So those of you who want to get really good GATE score, for them XE is something which is easy to attain, easy to get good GATE score and convert that GATE score into some kind of real good selection and then career. So you are watching the XE series, and in that you are watching fluid mechanics. I have covered some kind of questions, and this is my second lecture on fluid mechanics. This is the syllabus I discussed with you in the last class. I told you this is the syllabus of XE in the fluid mechanics. I think this is what we discussed in the previous class. Okay. So this is all what we discussed in the previous class, and now I will start from thereafter only. I will start from my next topic. This all we have already done, and yes, I think I will today. Yeah, this entire part was covered, and today I am starting some questions, real good question from viscosity. So if you ask me what is the surest question in XE in fluid mechanics, I will tell you that viscosity में से एक question 100% वो पूछता है, because Newton's law of viscosity is the most important topic in XE in fluid mechanics. Let me give you very brief of Newton's law of viscosity. See, Newton's law of viscosity is all about drag stress, shear stress, which further is used to calculate the drag force. And drag force is a very, very important topic in fluid. Drag force on the solids actually is the friction. So somebody asks you what is fluid friction? Answer is, sir, viscosity is the fluid friction. Why the viscosity, why the fluid friction exists? It is because of the intermolecular attraction. When the molecules have cohesive nature, intermolecular attraction, which eventually is viscosity, that viscosity leads to the friction in the fluid. So friction in solid and friction in fluid are different concept. Friction in fluid is because of intermolecular attraction. If I talk about liquid, I'm not talking about gas here. In case of gases, fluid friction is because of intermolecular collision, which we are not studying as of now. As of now, in the fluid mechanics, actually analysis we are doing is of the liquid as of now. So Newton's law of viscosity, if there is a liquid and it has viscosity mu, and viscosity further can be defined in two ways, dynamic viscosity and kinematic viscosity, I will discuss that. Then that shear stress can be calculated something like this. Now the terms which you should know are, there is something which is called velocity gradient. This direction is called longitudinal direction, this direction is called transverse direction. So as the fluid is flowing in the longitudinal direction, let me write certain things if I can do that. This is the transverse direction. Okay. Okay, so this is the transverse direction. Anyway, let me explain it otherwise. So this is the transverse direction. This one is the longitudinal direction. Transverse direction and longitudinal direction. Direction of the fluid flow is called longitudinal, and perpendicular to that is called transverse direction. So as you go in the transverse direction, which we call y, there is a velocity gradient because of fluid attraction. So because of viscosity, there is a velocity gradient. In the direction of y, velocity is continuously increasing, and at sufficient distance the velocity will become maximum, which is called free stream velocity. Now velocity gradient is related to shear stress. So what is Newton's law of viscosity? Shear stress is proportional to rate of shear strain or velocity gradient, and that velocity gradient is du by dy, and this particular constant of proportionality is called This is called dynamic viscosity or coefficient of dynamic viscosity. And this dynamic viscosity is found out as a slope of shear stress, rate of shear strain diagram, which we plotted in the last class. We discussed that in the last class. We were talking about that. Okay. So I think we can now directly start from this question. Read this question. Go through this question. If you can go through this question. Yeah, before that, I think this part we have already done in the previous class. Kinematic viscosity is dynamic viscosity over density. And then comes, there's a relation between dynamic viscosity, kinematic viscosity. And remember one thing, that in the numerical, whenever he will give you numerical, then in the numerical, how do you know dynamic viscosity is given or kinematic viscosity is given? From the units you have to identify. The dynamic viscosity is measured in different units and kinematic viscosity is measured in different units. Kinematic viscosity is nothing but a dynamic viscosity per unit density, and kinematic viscosity is measured in meter square per second, whereas dynamic viscosity is Newton second per meter. So that is from the unit only you will understand how it is to be measured. And this is the relation between the two. Just remember this relation and remember the units. And then one more thing, there are more units which are popular units are CGS units. So dynamic viscosity is measured in poise, whereas kinematic viscosity is measured in the Stokes. Poise, Stokes, Newton second per meter square per second. These units you should know for application of this particular formula, Newton's law of viscosity. And we are going to do some really good question today for this Newton's law of viscosity only. So let's now go directly to the question, and I want you to read this question. Read this question carefully. So this kind of arrangement is given to us. This is the arrangement which is given to us. So there is a basically inner cylinder and outer cylinder. एक cylinder के अंदर एक और cylinder है. There is one cylindrical basically container containing the liquid, cylindrical container containing the liquid, and there is another cylinder which is there and inside this particular outer cylinder, and one of them is rotating. Outer cylinder is rotating at 200 rpm. Inner cylinder is not rotating, outer cylinder is rotating. So radius r1 r2 for both the cylinders is given 3.5 centimeter and 4 centimeter. So we are given the radius of inner cylinder, outer cylinder, and outer cylinder is rotating at particular rpm, 200 rpm. And you know what, this depth of liquid is 8 centimeter. Liquid is filled 8 centimeter, and this 10 raised to minus 4 Newton meter torque is also given. So we can understand that this depth of the liquid in contact with cylinder is also given to us. Now we are assuming the profile to be linear profile. Linear velocity profile is given, and we have to find out what is the viscosity of the liquid. That is what we have to find out. We have to find out the viscosity. So read this question, stop this video here only, and try to see how do you find the answer to this. Do you find the answer? How shall you approach? So we are given the radii of the cylinders, we are given the outer cylinder rotation, we are given the liquid, and we are given the torque which is required to be produced at inner cylinder. So what torque is required? So how we shall find it out? Any idea what is torque? So torque is force into distance. Done. So where you are calculating the torque? So torque is calculated at the inner cylinder. So we are also to calculate the torque at inner cylinder. But how shall we calculate torque at inner cylinder? Can we find out the force acting at inner cylinder? Yes, we can find out the force acting at inner cylinder. That force is to be calculated from tau. If tau is multiplied by drag stress is multiplied by the contact area, that gives you force. And if force is multiplied by the radius, that gives you torque. And if torque is already given to us, we equate these two things and we get the value of the viscosity. So let us see how we are to find out the solution to this particular question. Now see this particular question. We are given the velocity. How shall we find the velocity? Pi d n by 60. We have to find out the velocity as 2 pi r n by 60. the RPM is of the outer cylinder. So outer cylinder ka radius is 4 centimeter. So 2 pi Rn, that means pi dn by 60 is the linear velocity of the outer cylinder. So the outer cylinder is having this particular velocity pi dn by 60. N is the RPM. So what is the velocity of the outer cylinder? That is 0.838 meter per second. You have to solve it and find out whether you are getting the correct answer. Because in the GATE exam, if you're writing GATE exam with XC, you can expect little long questions, and in those questions the accuracy is very important. So you have to solve on your own and find out whether you hit this answer. So that is 0.38 meter per second. Okay, we have found the velocity of the outer cylinder. Now do we know what is the basically gap? Do we know what is the gap between the two cylinders? Yes. So R2 minus R1 is the thickness. You know, outer cylinder is rotating, it has a linear velocity v. So the liquid in contact with the outer cylinder also has the linear velocity. Now if that linear velocity we know, and the velocity of inner cylinder is 0, so du is nothing but u, and dy is nothing but t. So t is nothing but R2 minus R1. So du by dy, which is used in Newton's law of viscosity, that du by dy is known to us. So if velocity gradient is known to us and mu we want to find out, tau can be calculated in terms of these two. So let me now find out what is the value for this. Go to Newton's law of viscosity. We have thickness now, dy is R2 minus R1, 0.5 centimeter. That means drag stress is equal to mu into u, which is this, divided by t, and t is to be written in meters. So this t is in centimeter, I convert that it into meters. So this 1.67 into 10 to a 2 mu, or 167.6 mu, is the shear stress which we got. Now that shear stress is helpful to give me the shear force. And remember that torque we are calculating at inner cylinder. So force, drag force is also to be calculated at inner cylinder. Let me ask you one question. This drag stress tau is acting at inner cylinder or outer cylinder or both? This drag stress is acting at both inner cylinder also and external cylinder also. So I can calculate the drag force by multiplying the contact area of inner cylinder, 2 pi r into L. And what is L? Is already given you up to what depth liquid is there, 8 centimeter. But convert that into meter, 0.08, 2 pi r, r of the inner cylinder in meters, that gives me area, contact area. If I know contact area, I find the drag force also. And if I multiply drag force with the radius of the inner cylinder, I get the torque. And torque is given as 10 to the minus 4. All you have to do is equate these two and calculate the value of mu. Remember that the dynamic viscosity ka CGS unit is poise. And how to convert poise into SI unit? You have to divide by 10. That conversion you, I think, already know. So Newton second per meter square is the SI unit. And that particular thing, if you multiply by 10, if you multiply this with the 10, 1 Newton second per meter square is equal to 10 poise. That conversion you know. SI unit into CGS unit, dynamic viscosity, all you have to do is you have to multiply by 10. So 1 Newton second per meter square is equal to 1 Newton second per meter square is equal to 10 poise. So SI unit into CGS unit you have to convert. This is a very good question, and I'm very sure you understood this. And these are the expected question for your XC fluid mechanics, what we are doing. So don't miss these questions. Okay, so let's go next and see this particular question. Now read this question carefully. Before I discuss this question with you, read this question carefully. Okay, there's a circular disc of radius r and it is kept at a small height h. A small height h it is kept above a fixed bed by means of a layer of oil of dynamic viscosity mu. If the disk is rotated at an angular velocity omega, what will be expression for viscous torque on the disk? Assume linear velocity profile. Now this is another form of question. Newton's law of viscosity mein, the question is asked from 2-3 different areas. Relative velocity between two components is required to get du by dy. Now this is a new system. There is a circular disc of radius r and it is kept at some height above the bed, and there is a liquid of dynamic viscosity mu between these two, and the disk is now rotated at angular velocity omega. You have to find out the expression for viscous torque. What will be the torque? So first we should imagine what kind of basically this what kind of diagram is given. See, now this is the shape he has given you. There is a disk which is rotating at angular velocity omega. There is a circular disk of radius r. It is rotating at angular velocity omega, and this plate at the bottom, it is stationary, and there's a liquid between this disk and the plate. There's a liquid between the plate and the disk, and now this disk is rotating. That is what is given. Now how to find out the torque acting? Okay, we need to find out the force acting. Remember one thing here, that in this particular case, the velocity, the relative velocity between liquid and disk, liquid and plate is variable. It is not constant. पिछले case में the velocity u of the cylinder, everywhere linear velocity was same, but in this case you see the linear velocity, this disk is rotating with the angular velocity omega, but if you go on the extreme side, the linear velocity on the extreme side will be different. Something like fan के सेंटर में लीनियर वेलोसिटी 0, फैन के एक्सट्रीम में लीनियर वेलोसिटी इज टेंशियल वेलोसिटी इज pi dn by 60. So as you move away from the axis of rotation, linear velocity keeps on increasing, and if linear velocity increases, du by dy में जो u है that also changes, and if u changes, then we need to think of concept of integration. So let's see what is the question here for us. We consider small element dr at a distance r from the axis of this particular disk which is rotating. So we take the axis of the disk is rotating at omega, and we take small element of length dr at a distance r from the axis of the ring. Now can you tell me what is the area of this small elemental ring? That area of this small elemental ring is 2 pi r into dr. That is area, right? And that area is a contact area. Now if I get the tau through Newton's law of viscosity, shear stress through Newton's law of viscosity, then this will be 2 pi r into dr into tau will be drag force. And if I multiply drag force with the radius, that will give me torque, and that is what I want to find out, but I need to integrate in this particular case. So let's go this way. What is the shear stress now? This is mu into du by dy. What is du by dy? Velocity of the liquid here over h. So what is the velocity of the flat plate? 0. What is the velocity of the ring? What is the velocity of the disk? U. And what is the difference between the two? H. So u by h, linear velocity profile assumption. What is the shear force? Sir, shear force is shear stress into contact area. Contact area किसका? ये जो elemental हमने strip लिया, इसका 2 pi r into dr. So this will be the shear force. And what is the torque? Sir, force into radial distance, because torque कितना लगेगा? अगर force पता लग गया तो force into distance, radial distance is the torque. So I get the torque also here. But this is the elemental torque. Now if I want to find out entire torque, I need to integrate. But one more thing, अभी तक हमने u का वैल्यू सब्स्टिट्यूट नहीं किया. What is u? u in this case is r into omega. अगर मेरे को फैन का टेंशियल वेलोसिटी निकालना है, फैन इज आल्सो लाइक अ डिस्क, यू नो, सर्कुलर डिस्क. फैन का शाफ्ट है ये, और ये रोटेट कर रहा है. थिंक इट ऑफ एज अ विंग्स ऑफ द फैन. ये वैसे ही रोटेट कर रहा है. सो टेंशियल वेलोसिटी इज r into omega. ओमेगा इज कांस्टेंट टर्म एवरीवेयर. सो r into omega मैं यहां पे लगा देता हूं. तो देखो मेरे लिए एलिमेंटल टॉर्क कितना मिलेगा? एलिमेंटल टॉर्क इज म्यू. u की जगह मैंने लगा दिया r omega over h, 2 pi r into dr. That is all I did. Now integrate it. Integrate it from r is equal to 0 to capital R, and this is what the total torque we have got it. Believe me, in Newton's law of viscosity, there are 5 to 10 good questions. In fact, 10 to 15 good questions, if I tell you that. And if those 10 to 15 questions, if you do numericals, GATE में वहीं से question आता है, whether XC or mechanical or something, but same question is going to be asked. And even when you go forward in BARC or ISRO interviews, he will ask you, he will give you these kind of questions. So when you say कि सर इसरो में एक मेरे को डेरिवेशन बनाने को दे दिया, ऐसा डेरिवेशन बनाने को देता है कि you go on the board and take a disc and it is on the plate, now rotate it. अब बताओ उसके ऊपर टॉर्क कितना लगेगा? Something like that, you have to find it out. So I hope this question is clear. Let me go to now third fundu or Foru question. You are doing 5 Foru questions, 2 Foru questions I have given you. This is now third question. Really good question from this, really good question from viscosity. A conical thrust bearing idealized as cone of vertex angle 2 theta. So there is a cone of angle 2 theta. Maximum cone radius r rest and revolve over uniform fluid layer of thickness T at constant angular velocity. Read this question. If the fluid has dynamic viscosity mu, you have to find out the expression for the torque required. Read the question first. So this is the third Foru question from Newton's law of viscosity. Now it is given as a conical shaped body to us. There is a conical thrust bearing. You know the thrust bearing? The bearings which actually sets against the that particular wedge. So conical bearing दिया हुआ है, cylindrical bearing नहीं दिया हुआ है. Cylindrical bearing is like this, thrust bearing is like this. Conical shape thrust bearing and उसका vertex angle 2 theta है और maximum cone radius r है and it is resting and revolving over a uniform fluid layer जिसका thickness t है at constant angular velocity omega. So this is the third case now and we have to find out the torque expression for this. Let's try to find out the answer for this. Okay, now see this particular shape. Conical bearing जिसका maximum radius r, this vertex angle 2 theta, it is rotating at omega. The distance between the wedge or thrust and this particular end section and conical thrust bearing is a T. There is a liquid inside it. Now how to approach this question? Now you understand, we will take at radius r, let's say any radius r pe, we have taken at radius r a small element of length ds, a small element of length ds. We are taking this length ds. Small element we have taken of length ds and this element is taken at radius r. And we will find out what is the torque acting at this element. I hope you understood. This elemental slanted length I have taken and on slanted length I have taken element ds. Now if you see in this particular case, then what we get here is, okay, what we get here is this ds, this is dr and this angle is theta. So there is a relation between dr, ds and theta. There is a relation between dr, ds and theta. And that relation is sine theta is equal to perpendicular over hypotenuse. So sine theta is equal to perpendicular over hypotenuse. It is something like this. This is ds, this is theta, this is dr. I have taken one section at distance r and I have taken elemental strip of length ds. This is what I have taken of length ds. Now sine theta is equal to dr over ds and from here ds is equal to dr over sine theta. I can do like this. And what is the area of this elemental strip? This is 2 pi r into ds. Now what we want? 2 pi r into ds is the elemental area of this strip. Elemental area of this strip. And then I can replace ds with dr by sine theta. Now what will be the shear stress? This is the mu dynamic viscosity du by dy. And what is du by dy? Let us say velocity here is u. The velocity here is u, which can be found out as r into omega. So this u again is nothing but r into omega and t is the thickness given here. And what is the drag force? Drag force is the drag stress multiplied by this particular elemental area. And what is elemental area? 2 pi r into dr by r sine theta. And what is the torque? Torque is the shear force multiplied by radius, that is r. So as you can see, this entire expression is in the form of now r, and if I integrate it, then I need to integrate it from r is equal to 0 to r is equal to capital R. So this is the expression of torque which I've got, and now if I integrate it, I get the total integration from r is equal to 0 to r is equal to capital R, and this is what the torque is obtained. So let me tell you, this is the third case in Newton's law of viscosity from where you can expect the question, and really good question. So one was now disc rotating, another was the cone, and the first question which we did was a cylinder rotating inside another cylinder. These three are really very good questions on the basis of which you can solve the Newton's law of viscosity questions, and they are very good questions, so revise these well. Okay, so let's go to now this question and let me see whether you can answer this. There's a cylindrical block of weight 5 Newton, diameter is 30 centimeter and height is this. It is allowed to slide down on an inclined plane, making an angle 45 degree with horizontal. So you see there is a cylindrical block of diameter this and height 2 centimeter. So this is the cylindrical block which is given to us. Now what is this cylindrical block? It's now diameter is given as 30 centimeter. We are given the diameter 30 centimeter and the height is given as 2 centimeter. This is 2 centimeter. Now this cylindrical block is made to come down. It is made to come down. Only thing is, I think we need to clarify this in the question little bit more, that the cylinder is coming down and the angle is 45 degree. Cylinder is coming down on this slanted part with this particular cross section. Cross section, it is coming basically 30 centimeter cross section is this and the height is 2 centimeter. So cylinder is coming down like this, right? So it is coming down on this surface. Uniform oil layer of thickness, this 0.01 centimeter is there. So this thickness is also given to us, and there is a velocity with which it is coming, that is 10 centimeter per second. That is also given. We have to find out what is the viscosity. So this is the terminal velocity. You know, this question combines two concepts. One concept is of motion along a slanted height, motion along a slanted surface because of the weight component. If you talk about its weight, it has two components of the weight. Let's say this is mg. So this particular component is mg sine theta, and the drag force is acting upward, and drag force is nothing but drag stress into contact area, and contact area is nothing but the area of this particular section. Do you know what is the area of this cross section? Yes, if I know the diameter, this is pi d square by 4. This area is known. You know what is the tau? Yes, tau is mu into du by dy. What is du by dy? Sir, velocity is given and thickness is given. That is du by dy. That gives me tau. Tau into cross section area gives me drag force. That drag force is equal to mg sine theta. Now this mg is nothing but 5 Newton. That is a weight. We equate it and we solve this question further. So very simple question. Hardly there is anything in this. Now see this question carefully. See the answer carefully. So we have to find out the tau. So tau is du by dy into mu. So what is the force here? Drag force. Drag force is mg sine theta. Mg is 5 Newton. Sine 45 degrees 1 by root 2. So 5 by root 2. This much is the this force acting downward. And the same force is nothing but that is a drag force. So as you see, there will be a drag force acting, and that drag force will be acting on the upward direction. As I discussed with you, this is the area of cross section which is given to us. So area of cross section, from there we can find out what is the drag force. So shear stress is mu du by dy, mu into u by t, that is a shear stress. Shear stress into area of cross section is nothing but drag force, and drag force is nothing but we have already calculated it. So if you equate these two things, from there you will calculate what is the value of mu. So the question was find out the coefficient of dynamic viscosity. That was the question given to us. Yeah, so Sudipto looks like have given correct answer. Believe me, these are the questions from where XE paper can be set, because they are very good questions on the basis of which you can prepare for this paper. So should we go for this question now? This is the, I think, fifth question, Foru question. There's a shaft and there's a sleeve, and these both are filled with Newtonian fluid. There's a shaft and then concentric sleeve filled with Newtonian fluid. Sleeve attains a speed of 60 centimeter per second when force is applied on it. What force is needed if it is desired to move the sleeve with the speed of 300 centimeter per second? So read this question again carefully. I'm very sure you will solve here. There is a clearance space between shaft and concentric sleeve which is filled with Newtonian fluid. You need to visualize the situation. Shaft is there, and then there's a concentric sleeve is there. Now sleeve is rotating when some force is applied on it and its tensile velocity is given. What force is needed if it is desired to move the sleeve with speed? So if this force gives this speed, what force will give this speed? That's the question. So can we make some kind of formula between force and speed? Shaft, sleeve. Shaft is not rotating, sleeve is rotating. First question, cylinder inside cylinder, something like that. Okay, done. I'm very sure you can find the solution to this. Let's go to Newton's law of viscosity. Tau du by dy into mu. Let's assume the linear profile. Du by dy is equal to u by t. There is an assumption behind that. So velocity gradient, whenever you write velocity gradient du by dy as u by t, u by x, u by h, the assumption is linear velocity profile. Majority of the questions may linear velocity profile will be given. So you get u by t. Okay, done. And if this is the drag stress, how do you find the drag force? So drag stress into area of contact is giving me drag force. Okay, done. So what is the drag force? Drag stress mu u by t into area, contact area. Okay, now you see, I'm not changing the contact area between sleeve and shaft. Am I changing the contact area? Same shaft, same sleeve. I'm only changing the force acting on the sleeve and the speed. These two things only I'm changing. So read the question again. If I can go back, read the question again. Sleeve attains the speed of this when force is applied on it. What force is needed if sleeve is to rotate at this speed? So force on the sleeve and velocity of the sleeve. These two things only are changed. Now let's go back to this formula. Area I'm not changing, mu I'm not changing, t I'm not changing. So force is proportional to velocity. That means F is proportional to U. That means F1 by U1 is equal to F2 by U2. So if the force are given, velocity are given, I can find out the solution to that. Really good question. Simple question, good question. So I think these were the questions which I think I collected for the discussion today. 4 to 5, these are taken from our regular series of this subject, fluid mechanics, which actually is expected in the fluid mechanics in XC paper. Really good questions, solve questions. Entire series, if you solve 5-10 questions from different topics, at the end you will get hundreds of good questions of particular subject from where in the exam question will come. So these were 4 to 5 questions from this part, that is Newton's law of viscosity. And these questions are also important if you want to later on clear some interviews, because these are the things, concepts which actually are asked in those interviews also. So exams plus interview, prepare well. Hope you understood this. Now I take your leave and I'll come back again for the next 5 questions from our regular series. Thank you. लिखा नहीं जा रहा था यार आज.